So the learning target for this video is to divide polynomials. This is like a how-to video. Learning target. Use methods, both visual and algebraic, to divide polynomials. Okay, so we're going to look at this method here, which maybe might come across a little bit weird at first, but I'm going to get out my colors, and I think you guys are going to follow along, I hope, and all my colors. And we're going to be looking at how do we multiply, thinking about division as the inverse operation of multiplication. So let's say I'm going to take this quadratic and I'm going to multiply it by a linear, expecting to get out a cubic. So quadratic by linear gives us cubic. 2x cubed, and then I can expect that these two terms here and here, 6x squared and 3x squared, are going to be like terms. And then here and here, I'm going to get 9x and 8x. Those are both like terms, both to the first power. And then here I'm going to have 24. So I'm going to use my colors here to really highlight what's going on. So 2x cubed plus 9x squared plus 17x plus 24 is equal to 2x squared plus 3x plus 8 times the linear function x plus 3. So my cubic was created from this. So what we're going to do is we're going to see if we can go backwards, kind of undo the process. So let's say I know that I have 2x squared and negative 35, and then I have two numbers here and here, which are going to add together to give me positive 3x. These right here should give me positive 3x when I add them together. So backtracking, x times what is 2x squared? Well, it's got to be 2x. And then 5 times what is negative 35? It's going to be negative 7. So 2x times 5 is going to be 10x. And I know this needs to be 3. So this would have to be negative 7x, which does check out with what we would have expected it to be. So x plus 5 times 2x minus 7 equals 2x squared plus 3x minus 35. So what we're going to do is we're going to sort of expand this idea out to a larger scale. And we're going to say, well, if I have a cubic and I want to divide out a linear function, how could I do that? So let's see, x plus 2, we're going to have 2 rows, and then we're going to have some columns. So 2x cubed, and then we're going to have x squared, and then we're going to have x, and then should have our linear down here. So maybe it gets a little big. We might have an extra box here. So 2x cubed was from 2x squared. Okay, so that's this component. Now 9x squared is going to come from the sum of these two boxes. Just like up here, those diagonals create what would be our square terms, our linear terms, our constant terms. So 9x squared is going to be those two added together. Well, I can figure out what this one is by saying 2 times 2x squared is going to be 4x squared. So I have 4x squared, I need to get to 9x squared, so 5x squared. Which means that this piece right here has to be 5x. Now let's do 7x. This number right here and this number right here have to add together to make positive 7x. All right, well, I could figure out this term because this is 2 and this is 5x. So this must be 10x. Well, if this is 10x, what is this? Well, if I have to get to 7, then I'd have to subtract 3x, which means this term has to be negative 3. All right, let's do our last one. Turns out these boxes were irrelevant. I know negative 3 times positive 2 is negative 6, so it does check out. So I want to make sure that everything works. Go back through. Okay, 2 times x squared, 2x squared times x, 2x cubed. 2 times 2 gives me 4, x squared, x times 5x is 5x squared. Add them, I get 9x squared. 2 times 5 gives me 10x, and then that means that x times negative 3 is negative 3x. Does it add to give me 7? Yep. 2 times negative 3 gives me negative 6, so check. So I could say that this polynomial, this cubic, divided by this linear equation is 2x squared plus 5x minus 3. Okay, so this right here is how we use our area model or our box method. If you wanted to look up more videos, I've seen it called the grid method as a way to divide. So this is one strategy in which we can divide these kinds of functions. Now, these only work, well, these are only examples of ones that have no remainder. So for now, this is with no remainder. And we may decide to come back later and look at some with remainders, but this is just sort of helping us to build an understanding of what it means to divide a function by another function and get an output. So the next video will be over more of a algebraic interpretation of dividing polynomials. So this is visual, and then we're going to look at algebraic operations next.